Good morning, students. The lecture we are going to learn today is from four pillars of IoT. Yesterday we learned about the four pillars of IoT. They are M2M, machine to machine, which is in another form called as Internet of Device. Wherever in the device-oriented IoT we are using like smartwatch, then wearable devices, which is used for healthcare applications. That all are comes under machine to machine, which is Internet of Device. And the remaining three pillars are RFID, wireless sensor network, and SCADA. So today we are going to learn these three pillars of IoT. Okay, so the second one is RFID. Another form of RFID, we can say it is Internet of Object. Okay, so wherever we need this RFID tag, in that object we can paste this RFID tag and we can easily able to scan the details. Either it may be a price, description, whatever it is. Okay, so the RFID is a low cost disposable contactless smart card. Okay, we can say it is a smart card, so which have includes with the small chip. Okay, so which it stores the static number, like an ID number. All of you have an register number, unique identification purpose. Okay, so same thing, this RFID tag also have a chip which is used to identify a static number for every object. Okay, and it have an attributes of the tagged object like its price, manufacturing date, and some details what brand it that particular object is. Okay, this everything is included within this RFID tag. So to transmit the data, we have antenna that enables the chip to transmit the stored number to a reader. So we need an RFID reader. Okay, tag we can paste it to the object, but whenever we are scanning the object, we need the reader. So in that reader, the antenna is fixed to which can be able to transmit the particular data to the reader. So in between, in the middle, we need a RFID software as a middleware. Okay, so when the tag comes within the range, we have a specified range for the RFID tag and the reader. Okay, so when the tag comes within a specified range, the RFID reader can able to read the particular data and transmitted the ID as well as attributes to the reader. So it's called as a contactless smart card to store large kind of data. Okay, more data. With the support of small static number, we can able to transmit large data. Okay, in previous to this RFID tag, we may use the barcodes. Okay, we need a barcode scanner to read the barcode. You can see this barcode here. Okay, this all are kind of barcodes. Okay, two types of barcodes are there. UPCA, which is having 12 digits. These 12 digits are separated by number system, then manufacturing code, product code, as well as check digit. Okay, the next form is EAN 13. It is also splitted into four forms like number system, manufacturing code, product code, and check digit. Okay, so here the check digit is numbered at two digits. That's why it is called as 12 digit, differentiated by 12 digit and 13 digit barcode. Okay, so in parallel to this RFID tag, we are using this barcode also. Okay, one of the initiative of this RFID radio frequency identifier is a barcode only. Okay, so this RFID tag can be named in or utilized in three forms called as active RFID tag, passive RFID tag, and semi-passive. Okay, so active means which has an board battery, it broadcasts the signal. Okay, so it have the battery. That's why it is called as an active RFID tag. Okay, so with the support of that battery, we can able to transmit the broadcast the signal. Okay, then passive RFID tag means it does not use a battery. Okay, semi-passive means it have a small battery on board that is activated when the presence of the RFID reader. Okay, is it clear? So the RFID tag is split into three types: active RFID tag, passive and semi-passive. Active RFID tags have a battery to transmit the signal. Passive doesn't have a battery. Semi-passive, which have a small battery, when it is nearer to the RFID scanner, it will be activated. Okay, this was the difference between these three kinds of RFID tag. Okay, so to read this RFID tag, we must need the RFID scanner. Okay, so the best example we can say for RFID tag is FASTag. Okay, nowadays it is mandatory to use FASTag in every cars. Okay, so this is the example for FASTag, and this kind of keychain like RFID tags also available nowadays. Okay, so these are the components integrated with the RFID tag: a small microchip, then subtract, as well as antenna. This antenna could be used to receive the signal. Okay, this is the chip which is inserted for the RFID tag. Various kinds of RFID tags are available nowadays. Okay, it may be in cars, keychain, house, etc. Okay, so in this RFID, various frequencies are available. Okay, for different kind of application, different kind of RFID frequencies are used. Okay, so some kind of RFID frequencies, its key applications are mentioned here. The first one is 125 kilohertz, which means it is a low frequency RFID tag. Okay, so it's an inexpensive passive RFID tag. It is just used for identifying animals. Okay, in the wildlife forest field, we can use this kind of RFID tag. Okay, then the second one is 13.56 megahertz. This is called as high frequency RFID tag. So this kind of passive RFID tags are used in library book identification, cloth identification. Okay, so in that places, in our library also, every book is tagged with this kind of tags. Okay, there we can use this. Then third type is 400 megahertz, which is called as ultra high frequency. So this is used in remote control for vehicle center locking system. Now in nowadays, in the car keys, we are using this kind of RFID tags. Okay, whenever we are nearer to the car, with the support of the keychain given to this car, we can able to unlock the car as well as lock the car. Okay, so in that application, we are using this kind of radio frequency. Okay, then the next one is ultra high frequency RFID tag. The frequencies are 868 megahertz to 922 megahertz. Okay, so this is for active and passive RFID tag, which is used in different countries like Australia, in logistic, as well as various fields. We can use this ultra high frequency RFID tags. Then the final one is megawatt. Okay, so this megawatt radio frequency tags are between 2.45 gigahertz to 5.8 gigahertz. This may be mainly used for vehicle identification, as well as with this temperature sensor or GPS localization. In this bands, we can use this megawatt RFID tags. Okay, so the megawatt RFID tags are used in the vehicle identification, highway data collection, highway toll. Okay, so what kind of fast tags we are using? So 5.8 gigahertz megawatt RFID tags we are using. Okay, for highway data to highway toll collection. Okay, so this is about RFID tag, and these are some examples. Okay, then the next thing we have to see is next two pillars are wireless sensor network as well as the SCADA. Okay. Okay, the third pillar of IoT is wireless sensor network. It may also be called as Internet of transducer. Okay. So, Internet of Transducer. Before moving into WSN, you have to know what is transducer. Okay, transducer means it's an electronic device which convert energy from one form to another. Okay, the best example for the transducer is microphone. We can hear songs using microphone. We can talk to others. We can get the energy in the form of noise. Okay. Another example is loudspeaker, then thermometer. We can get the output in the form of temperature, degree. Okay, then position and pressure sensor. This all are example for transducer. Okay, it converts the energy from one form to another form. In the receiver side, we can see the output in the form of either in number, digit, sound, etc. Okay, then the use of wireless sensor network is it mainly supports to sense and collect the data with the support of the sensor. Okay, various kind of sensor is available in the market nowadays. So using this sensor, we can easily able to collect the information. So using that information or data, we can do further processing. We can make a decision. Okay, lot of applications are available with the use of this wireless sensor network. Okay, like temperature sensor, pressure sensor, etc. So the some wireless sensor networks used are represented here, like body sensor network (BSN), then visual or video sensor network, vehicle sensor network, underwater, urban, then interplanetary, field bus network. So these kinds of networks or sensor are available. So first one we can see is BSN, okay, body sensor network. So this is a wearable kind of sensor device we can use mainly for the healthcare purpose to monitor a body temperature, heartbeat, pressure, whatever it is. Okay, so based upon this kind of data, a human body can be easily monitored in a remote place. Okay, wherever the doctor is available or not, we can able to monitor a person's health very easily. Okay, nowadays wearable smart watches and wearable bands are available to monitor the physical health of a person. Okay, so that was the best example for this body sensor network, mainly used in the healthcare domain. Okay, this is just an architecture diagram which supports we can wear this kind of devices in our hands, legs, etc. Okay, so here the sensor nodes are activated to receive the data, and it would be transmitted to the central server with the support of access point as well as the internet connection. The next kind of wireless sensor network is the visual sensor network. Okay, so this kind of sensor network is processing by taking the images, observing the images. Okay, it may be CCTV image, cameras fixed everywhere. Okay, so the image or vision processing is done by this visual sensor network, which can be used in the embedded system processing. So this VSN, visual sensor network, can be used in the surveillance, environmental monitoring, smart homes, virtual reality. Sometimes there may be no caretaker for our kids. So at that time, we can fix the surveillance camera within our house and we can monitor what our kids are doing. Okay, so in that kind of places, we can use this visual sensor network. The next is next we are moving to wireless sensor network. Okay, wireless sensor and actuator network. So which is capable of processing the data in the physical world. Okay, so which is supported in the application area like nuclear, biological, home automation. Okay, what this wireless sensor and actuator network is doing is it gathers the data, process it, make an observation. Based on the observation, it is making a decision. Okay, for like smoke sensor we are using. Okay, if the smoke of the particular gas is little high, it creates an alarm. Okay, So if there fire happens, based upon the environmental condition, what sensor we are using, it creates some alarm. Okay, so it is based upon the decision it took. Okay, so that kind of environmental condition, we can use this wireless sensor and activator network. So it can observe the physical condition or environmental condition, observe the data, process the data, and make the appropriate decision. Okay, so this can be used in the home automation, nuclear, lot of surveillance, as well as microclimate control in building. Everywhere we can use this wireless sensor and activator network. Okay, then come to our main topic, wireless sensor network. This is the architecture of the wireless sensor network. It is divided into three tiers: tier 0, 1, and 2. Tier 0 is just a sensor fixed in every place, which is used to just sense the data, and all data is computed in the tier 1 with the support of transceiver received data. Okay, so all data received by the sensor is computed in the second tier, and it is finally delivered to the main server. Okay, which means embedded system to process the data or to take a decision, whatever it is. So this is the basic architecture of sensor network. Okay, so a lot of sensors are present in the particular object or wherever it is fixed. From that, we can able to get the data to compute it in the tier 1, and finally it is delivered to tier 2. Okay, so the topology of wireless sensor network is sensor node, base station, as well as the operator. So you'll know sensor node, which manipulate or sense or read the data, and it is communicated to the user or operator by the support of base station, and the task manager or operator is doing a decision or sending a query to the server. Okay, so here in this wireless sensor network, we are using the concept of routing. Okay, so we are using some kind of routing protocols to distribute as well as the transmit the data, as well as we can use some algorithm like demand distance vector algorithm, dynamic source routing algorithm to transmit the data very fast in a wireless sensor network. Okay, so these are some issues: energy, routing problems are there, lifetime maximization. These are the some issues addressed in the wireless sensor network. Okay, so these are two types of sensor network. The sensor network may be static sensor network or mobile sensor network. Static sensor network means the particular sensor which is fixed or not moved to any places. Okay, so it is flooded across the network and it is a fixed one. But mobile sensor network, it can be moved under control. Okay, based upon the environmental changes or based upon the decision took place. The sensor may be moved, but we can easily gather the data. Okay, so this is the third type of IoT pillar. Okay, wireless sensor network. So in this wireless sensor network, we learned the mainly three major types: body sensor network BSN, visual sensor network VSN, then wireless sensor and actuator network WSAN, then finally about wireless sensor network. So this mainly this wireless sensor network we can use in the military applications, radio transmission with antenna, microcontroller, etc. Okay, then the fourth pillar of IoT is SCADA. Okay, supervisory control and data acquisition system. This was the very best system mainly used in the major industries, and lot of IoT applications are available using this SCADA. Okay, this SCADA is the main pillar of IoT. Okay, this includes our remaining two pillars, remaining three pillars: M2M, then RFID, wireless sensor network. Everything can be included within this SCADA. Okay, so it is supervising as well as controlling the entire environment. Okay, the main two applications we can see here is building automation system BAS, as well as industrial control system ICS. Okay, building automation, you all know the entire house can be controlled with the support of IoT technology nowadays. Okay, in our country it is not that is full-fledged the IoT automation. But in foreign countries, full-fledged IoT systems are available. Okay, that was comes under this building automation system. In our country, just we are buying fridge, washing machine, everything separately based upon our need. But in foreign countries, this all electronic things are inbuilt within the house. Okay, we can easily able to control this using our smartphone, remotes, etc. A fan, a light, whatever it is. Okay, that is called as building automation system, which is executed with the support of this SCADA. Then second major application of this SCADA is industrial control system, ICS. So which is computer system that monitor and control industrial infrastructure or facility based process. Okay, it is divided into three kind of process. First one is industrial process. Industrial process means in manufacturing, production, power system, which means in EB, electrical field, then refining, fabrication. In these places, a 24/7 operation is going on in the machines. Okay, as manually we can't able to view and do this works properly. Okay, so these all industrial processes are controlled and perfectly done by this IoT system, by industrial processes and industrial control system. Okay, then the second one is infrastructure process. Infrastructure process means wastewater management, wastewater collection and treatment, then oil and gas pipeline checking, electric power transmission. This oil and pipelines systems are very crucial to check whether any leakage is there or not. If it is IoT controlled, we can easily able to get the details whether the pipes are okay, whether it is working in a good condition or not. Okay, so in this infrastructure process, this ICS can be used in then civil defense, then very big transportation systems everywhere. We can use this infrastructure process based SCADA. And the third one is facility process. Facility process used in public as well as private facility, in building, airport, ship, space station, everywhere we can use this facility process, which is facilities we are providing to the public. Okay, ticket verification, allocation, everything is facilitated by the SCADA application. So these are the three processes comes under industrial control system, ICS. These are some components of SCADA: human machine interface, then remote terminal unit, programmable logic control, and distributed control system. These are the utility automatics or components available in the SCADA. Using these components, we can able to get the environment details, and we can easily able to take a decision or whatever it is. And this is the middleware based SCADA system. The middlewares are hardware, protocol stack. Then over the middleware, it is service and application manager and application layer. Okay, so various kind of hardware devices. It may be camera, USB, LCD, keyboard, power management, SPA. A lot many things or hardware we can use to receive or grasp the data. Over that, some protocol stacks are used to get the data in a proper way from the network. Okay, and in the middleware, we are using some service and application managers called device management, security, and Java based application. Over the application layer, we can get the data or use this SCADA system in safety purpose, system configuration, web browser, remote monitoring, etc. Okay, so this all about the four pillars of IoT. In the previous lecture, we learned M2M, Internet of Device, and today we learned RFID, Radio Frequency Identifier, which is Internet of Object, which is mainly used in the wearable devices, as well as, the Internet of Object, which means radio frequency tag, rather than the barcodes. Okay, main application for this RFID is FASTag. Okay, then the third one we learned is wireless sensor network. It is BSN, VSN, and WSAN, as well as the WSN. Finally, we learned, and the fourth pillar is the SCADA, which is Internet of Controller. Okay, in very big industrial applications, industry sites, this SCADA application as well as IoT technology is very much needed nowadays. Okay, thank you.